Hello and welcome to this repair tutorial, and today we're going to look at a Cambridge, and this is an A500 amplifier. In terms of general specifications, power output RMS is 60 watts per channel into 8 ohms. This amplifier also supports bi-wiring, and then input sensitivity is 250 millivolts for all of your inputs. If you insert the optional phono board, which is designed for a moving magnet type cartridge, that is 1.75 millivolts at 47 kilo ohms. And this amplifier also has a preamplifier output, so you can connect to additional power amplifiers if you wish, and that is 500 millivolts. And then frequency response is 10 Hz to 60 kHz. And then in terms of distortion, it's less than 0.02% at 1 watt. And then dimensions, height is 90 by a width of 430 and a depth of 300 millimeters. And then the weight of the amplifier is 6.2 kilograms. So what was the issue with this amplifier when it came into the workshop? Well, it really had a rather odd fault, and one that I've not seen previously, and I literally have repaired hundreds of these amplifiers, including the similar amplifier like the A300, A5, etc. And what the customer reported was that if the amplifier was maybe running for 20 to 30 seconds, what they would hear is that the left channel went off. But this amplifier doesn't, for example, have a speaker protection relay, so it wasn't associated with anything like that. And then also as well, in terms of the input selection, you can maybe think, okay, well, maybe it was the input selection, but it wasn't. The amount of time that it required for that fault to appear when the amplifier was switched on from cold was probably about 10 or 15 seconds longer than maybe if you saw the fault and then you switched off the amplifier and then turned it back on again within a few seconds. Then the audio then would phase out probably in about 4 or 5 seconds. The other interesting thing is if you depowered the amplifier, as the power supply then effectively collapsed down, i.e. the capacitors discharged, momentarily you would hear the left channel come through crystal clear, and then of course there would be no audio then on either of the channels. But before we get into what was causing that issue and that fault, there were some other things that we needed to take care of. So on this photograph here, what I'm showing you is the input RCA sockets. Now I do not know what environment this amplifier has been in, but when you look at those RCA sockets, they've almost just crumbled away, deteriorated. Something in the atmosphere has done something to that plastic. So it's not something you think, okay, well maybe I can glue that. You can't do anything with it at all. And all of the RCA socket connectors were all like this. Literally, if you gave them a little bit of a tap, it just sort of crumbled. So what we do here is don't waste any time trying to do any repair work. We just simply replace them all, and that's what you see here. So what I've done is I've just replaced every single one with brand new RCA input sockets, and then that puts in that longevity, so you're not going to have any issues in the future. And then on this photograph, what we're showing you is this is where you would plug in the optional moving magnet type cartridge circuit board. And the way in which you do it is you just insert the circuit board, you just have a locking nut which is on that screw terminal just to the right, and then you just have to cut 2 links at the rear where it just reroutes the signal from the input directly then through to the phono stage. And then the other thing which I noticed is that this amplifier, based on probably those RCA terminals, must have had extensive operation over a number of years. So these 2 voltage regulators here are directly mounted very, very close to 2 electrolytic smoothing capacitors, and these are rated at 47 microfarads at 50 volts. When you looked at them, they had already discolored, so instead of them being this lighter blue color, they'd faded out. And really those capacitors are sitting next to a couple of radiators, so that means that the components had aged very, very quickly over time. So what I do is I just check those capacitors on the ESR meter, and as you can see the ESR is 5.5 ohms, and the meter flagged up to say, look, this is a bad capacitor, so we just changed them out for 2 brand new ones, and we fitted some Nichicon capacitors. Now the issue with the equivalent series resistance being high is as electrolytic capacitors fail, this resistance will get higher and higher, and the last thing that you want with an electrolytic is this internal resistance, and that's why really on large power supply electrolytic capacitors often they read pretty much 0. As soon as you get the resistance, then the capacitor will then start to heat up because of the electrical resistance, and it will accelerate then the burn off internally then of the electrolyte and result in the capacitor failing completely. The other thing that we looked at was the Sanken output transistors, which we see here both for the left and then for the right hand channel. And there was something a little bit odd. The first thing is, and it's common, that you will find that the heatsink compound will have dried up and it's like a chalky substance. So you just need to remove the locking nuts on each one of the fixing screws, and then you can raise up the power transistors. And then on this shot, what we're showing you is that these are the individual mica washers which have been removed. And when you put it on the heatsink compound, you want to apply it to both sides of this, spread it around, and make sure that you've got good thermal transfer. But one of these mica washers had a hole in it. Now, maybe that was during manufacture, but that's a bit of a risky thing to have. So what I did there was just to replace that individual mica insulator, so there was no risk that the non-tab isolated power output transistor was going to short directly to the heatsink. So the thing that I want to show you here is an extract from the service manual, and what you're looking at is the tone control circuit board. Now what you have for that circuit board are individual plus and minus 15 volt regulators, which provide the power supply then to two operational amplifiers. So when we look from the rear, this is the tone control circuit board, and those operational amplifiers and associated circuit, including the regulators, are mounted underneath those bronze or gold covers. And then what I found out was that when I put my finger on top of those electromagnetic screening cans, you could feel some degree of warmth, which is a little bit unusual. So I kind of suspected maybe something was going on underneath. It could have been an issue maybe with the operational amplifier or something else. But the first thing that you have to do is to remove the tone control circuit board, and that's what we show you here. And then what I found was that if I did a voltage measurement, as you see here, for some reason the plus 15 volt 500 milliamp regulators were outputting the same input voltage at 27.55 volts. So no wonder the operational amplifiers were running high. And you could see what the issue was, that when you first switch it on, one side of the op amp was being driven excessively on its power supply positive pin, and then causing the IC then to effectively fail or shut down. And then here what I've shown you is I've first of all removed the integrated circuits, and then what I've done is I've just put a circle around the 15 volt positive regulator here. So this is one of the ICs, and then here what we show you is the second one. And the reason why I've done that is I just want to find out whether or not there was a fault with the integrated circuit which had caused the failure, or there was something going on with the voltage regulators. So I replaced both of the voltage regulators and then retested, and I had positive 15 volts, no high voltage at all. But because these two operational amplifiers, because they've been overdriven in terms of its power supply voltage, I simply replaced them. I didn't really want to take the risk that maybe the op amps, had been damaged. So once I replaced those, and of course also the 500 milliamp 15 volt positive regulator, no issue with the performance of the amplifier. You got clean audio, and during test you didn't get any sort of phase out or any loss of audio. But this fault is very odd. I've never seen that before. And also, why did two of these regulators appear to have exactly the same fault? Very odd. So once all that work was done, we also cleaned the user controls and then the switches with a high quality switch cleaner, and in this case it was De-Oxit D5. And then the final part then is just to do the bias for the output channels. So here we see an extract from the service manual, and you can see that this is the left channel. And what I'm interested to do here is to leave the amplifier on test normally for about 20 minutes, so it fully warms through. And then if you follow this along, and this is also detailed in the service manual, what you can see here is that we need to connect directly across pins S and E of the Sanken device. So this is the 15N device, the NPN version, and you read directly then across the internal emitter resistor the millivoltage, and you're looking to set that to 13 millivolts. And it's very easy to do, straightforward, no sort of concerns. And then also as well, which we do, is we always measure onto the rear speaker terminals just to check to make sure there's no high DC, and there wasn't. It was only 1.13 millivolts or thereabouts on both channels. But if you did have an issue, then you're looking at the very early input stage of the amplifiers where you see these long tail pairs. Don't bother to make any measurements. You would just simply switch them out and then just do some gain matching to make sure that they've got equal gain, and that would rectify that issue with any excess high DC. And then here what you can see is we are connecting across the MPN SAP15. We are measuring a higher millivoltage reading than what we should be. So you can see this is drifted up over time, over 17 millivolts. And then here, what we do is we just adjust it back down. So I'm looking at 13 millivolts overall, or approximately here. You'll see the multimeter just tick to 12.98, maybe to 13.01, but that is the alignment then taken care of for that channel. And then all that we do is we just repeat it the same. On this channel here, which is the right, just slightly high, not excessively high. And as we said, then we just corrected that pretty much to approximately 13 millivolts. And then here, when you look from the top of the amplifier, that's all the work completed. And then I also took the time just to do a measurement with the ESR meter just to check the remaining electrolytics, but all of the others were then within tolerance. Also bear in mind as well with these amplifiers that you should also check all of the circuit boards for dry solder joints, particularly on the amplifier board, that you do find multiple dry solder joints around. For example, the power regulators, which run, hot, and just re-solder or reflow all of those. On the input board, it's a little bit more difficult because they use like a black masking across the circuit board, so to sort of follow through your circuit tracks is not easy. But at least with the RCA sockets, you can verify to make sure that there's no sort of cracking around the solder connections there, and also on the user controls on the tone control board. And then here, finally, as we come towards the end, we're just showing you all of the components removed. So you can see there one of the RCA sockets just snapped completely in half. All of the others brown, maybe this is nicotine. There's that mica washer, which had the hole in it. And then the 2 voltage regulators, 15 volts positive, 2 operational amplifiers, and then also the 47 microfarad 50 volt capacitors. And then the only thing that then remained was just to pop the amplifier onto test. And here the amplifier ran for about 3 hours, delivered excellent performance. So that sort of brings us to the end of this repair tutorial. So if you have any questions or you need any guidance, support or assistance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any guidance that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.